Okay, now we're going to move into using the t-distribution table to test a claim about a mean. So the one we're going to look at primarily is going to be when we're looking at a population mean, when the standard deviation for the population is unknown. This is the most common case, so this is one we're going to focus on. Usually you'll be working with a population mean for your comparison that you're not necessarily going to know what the standard deviation for that population mean is. So let's take a look at an example. We're going to use example 12 on page 415. And here we're going to be going through and looking at the weights of discarded plastic from a sample of households. And we're going to use data set 23 from the Statscrunch. So make sure if you need to go back and take a look at that video that I have under using my math lab for looking at how you access Statscrunch for the data set. And we're going to go through and solve this problem using a significance level of 0.05. And we're testing the claim that the mean weight of discarded plastic from the population is greater than 1.800 pounds. All right, so that's the claim that we have. So let's go through our steps. And over here you see I've identified these out for the primary steps we're going to use. So the first step we've got is we need to check for the criteria. Then we're going to need to identify our test statistic, identify our hypothesis, do our testing procedures, and then come back with our interpretation and connect it back to the specific problem. So let's get started on this. So when we're looking at this, first of all, you're going to want to go and on your StatsCrunch, open up data set 23. And we need to look at this and ask ourselves some questions. So is it a continuous random variable? And does it have a population normally distributed, or is the n greater than or equal to 30? Okay, so take a few moments and look at that data set. Let's think about these different criteria and whether or not it meets these criteria. This is going to be a really important step. Do not assume that all the problems you're going to get in your homeworks or your exam readiness or on the exam are always going to meet the criteria for using the distribution. So when we're looking at this particular set, we can in fact see, yes, it's a continuous random variable because we're measuring it, thus we're weighing it by pounds. Okay, and we have an n that's greater than 30. We have an n of 62. Okay, so we're going to be able to go through with our testing for this claim. So we have that. The next thing we need to do is we need to identify our test statistic. What test statistic are we using for this problem? Again, you can't assume when you're taking the exam readiness assessment and the exam that you're always going to be using a t-distribution. So you need to check that. So we're going to go back and look at the table that we discussed previously in section 8.2. We're going to look here at our table to make our decisions. So we're looking at this. What parameter are we being asked to solve for? Are we working with in this problem? Well, we're solving for our mean. So we can see we've got our mean here. Now there's two different possibilities. So the next question we have to ask is whether we're using the z distribution or the t distribution. In order to do that, we're going to be looking at our standard deviation. So here we are told that our standard deviation is not known, right? So we have that. We're not given that information. We don't know what it is for the overall population. We only have it for a particular sample, okay? We are told that we either do have a normally distributed population, or in our case, our n is greater than 30, 62. So that means that we're going to be using the t distribution, and there, in fact, is our t formula, okay? Now, a quick subway, just to be clear. If we knew what our standard deviation was, what our sigma was for the population, the process is going to be exactly the same, except, as you can see, we use the z distribution. So that is the only thing that changes. If you do know the standard deviation, then you get to use your z distribution. If you don't know the standard deviation for the population, we're using the t distribution. Okay? So now we know our test statistic is a t. We need to identify our hypotheses. So let's go through the steps we looked at before. What is the property that we're being asked to work with here? So remember, we have three different possible properties when we're solving a problem. We can be solving it for proportion, we can be solving it for the mean, or we can call it for the standard deviation. So which property are we solving for here? Well, we're going to be solving for our mean, right? So we're solving for our mean, okay? So now we also need to go through and identify our claims. Now, I often find it easier to actually identify the alternative claim first, such as this example here, so my H1, because we can see that that's what's given to me here. So I'm solving for my mean, for my property, right? And then you can see down at the bottom it says that the claim that's the challenging claim here is that it's greater than 1.800 pounds. So that becomes my alternative hypothesis, or my H1, okay? Mu greater than 1.800 pounds. All right? Now we need to decide what our null is going to be. So what statement would disprove my alternative hypothesis? So if the mu is not greater than 1.800, what statement would show that that was not the case? Well, in fact, we can set it as being equal to. And we're going to see this makes it a one-tailed test, which makes it a little bit easier to refute our alternative claim. So we're going to be saying simply that the mu is not equal to 1.800. We're not saying that it's necessarily, we're not setting the criteria for less than. We're just going to set it for equals to. So we've got our mu is equal to 1.800. If that mu is equal to 1.800, then it clearly refutes the claim that it's greater than 1.800. All right, so now we have our hypotheses in place. All right, and now we're going to move into doing our testing. Okay, so here we have our hypotheses, our significance level. What's going to be our significance level for this particular problem? Well, again, it's going to be the 0.05 that they've given us there. Note if they don't give you a significance level at all in the problem, then you're going to want to use the default of 0.05. Now, we already identified our relevant test statistic because we identified it was a t previously, so we've already got that taken care of. And now we're going to move into, in this case, we're going to use statscrunch. So here we're going to use statscrunch. Keep in mind, again, when you're doing your homeworks and your exam problems, if it's telling you to use technology, then you're going to want to use your statscrunch. If it's not telling you to use technology, you're going to need to do it by hand and use the t-distribution table yourself. And we're going to look at that next after we solve this particular problem here. So if you're using statscrunch and you're going to go through and do this, here's where you want to go. So you're going to have your data set open. Again, we're data set number 23. You're going to go to t-stats, one sample, and that's the name of the type of t-test we're doing here. Notice when we come back and we're looking for exam 4, we're going to do these other two. We're going to do 2 sample and a paired. But for right now, we're doing the 1 sample t-test. You have the choice of either having your data set uploaded, which is the one we're working with right now, or if you have a problem where they provide the necessary summary values, notice that you would select the other option where you would be doing with summary. Okay, so take a few minutes. Again, you need to be having your statscrunch open while you're looking at this so you can orient to it. All right, in our case, we're already using the data set that we have for data set 23. You should already have that open. Okay, and here's how we're going to load this in to statscrunch. So you're going to select your variable here. You can see the purple. Okay, so there's the purple showing plastic. You're going to select on that, and it's going to move it over into the right-hand column. Next, you're going to need to enter your value for the null hypothesis. Okay, so remember our value that we had was 1.800. Okay, and so what you have here for your null for the hypothesis test, where we see mu equals 1.800, notice that should match what you have for your null hypothesis. Now, for your alternative, your what they call here HA, you're going to want to make sure you have the correct directional symbol from your H1. Okay, so in our case, we're looking at a greater than. So notice that I've set the symbol here for greater than. Notice that that then sets my alternative hypothesis of mu greater than 1.800 also corresponds with the alternative hypothesis that I generated. So when you're setting up your statscrunch, it's really important to make sure all of these are set. Notice statscrunch is going to do a t-test automatically for an alpha of 0.05. Okay, so that's what it's set for automatically. Once you have that, you're going to want to hit compute, and you're going to get an output somewhat like this. So here's our different samples that we've got. And again, you can see here over on the left-hand side, you've got your null and your alternative hypothesis specified. And here we're going to come across, and we know we've got our sample mean, our standard deviation. Notice there's our degrees of freedom, which is n minus 1 in this case, so 62 minus 1. And then we can see we've got our t-stat, right? So that's our test statistic. And we've got our p-value of 0.208. All right, so we get both of these values from our statscrunch output. Okay? Now, for right now, we're going to focus on doing the p-value method. We're going to come back in a separate one and look at doing the critical value method in a few minutes. But right now, we're just going to focus on p-value for this particular video. So I've got my p-value. which is 0.208. And notice I'm going to take that and I'm going to plug it in to ask this question, is my p-value less than or equal to point of my significance level? So here we have the question, is 0.208 less than or equal to 0.05, right? And we're going to answer these problems. And again, we've plugged this in. If the answer is yes, then we find that we reject our null. If the answer is no, then we fail to reject our null. So what is the answer here? Is 0.208 less than or equal to 0.05? No, it is not. So in this particular problem, we fail to reject the null. It stands. The challenging claim that it is greater than 1.800 has not been supported.